Hey guys, welcome back to the Aptos blockchain development course. Today we're building a to-do list application on the Aptos blockchain. Now you might think a to-do list, isn't that a bit basic? Well, yes and no. While a to-do list is a classic beginner's project, implementing it on a blockchain introduces some interesting concepts and challenges that are fundamental to decentralized application development. In this video, we'll cover everything from setting up our project to designing our to-do list structure using Move, which is Aptos' smart contract language. We'll implement core functionalities like creating, updating, and deleting to-do items, and even add some view functions. By the end of the session, you'll have a solid understanding of how to create a functional decentralized application on Aptos. So why build a to-do list on blockchain? Well, it's an excellent way to demonstrate key blockchain concepts like data persistence, state management, and user interaction with smart contracts. Plus, it's a relatable example that we can easily expand upon in future videos. So let's get started. Before we jump into coding, let's ensure our development environment is set up correctly. If you've been following along with our previous videos, you should already have the Aptos CLI installed. If not, please go through the docs from Aptos and set it up, or you can go to the first video of this series. The Aptos version command should display your installed Aptos CLI version. And after that, if you want to update it, you can run the Aptos update Aptos command. Now let's create a new Aptos project for our to-do list. Open your terminal and run aptos move init name to-do list. This command creates a new directory called to-do list with the basic structure of an Aptos project. Let's take a look at what we've got. In your to-do list directory, you'll see a move.toml file and a sources directory. The move.toml file is like a configuration file for our project, similar to package.json in Node.js projects or cargo.toml in Rust projects. It specifies our project dependencies and other metadata. The sources directory is where we'll put our move code. Create a new file in this directory called to-do-list.move. This is where we'll write our to-do list smart contract. Now that we have our project set up, let's think about how we want to structure our to-do list. In a traditional application, we might use a database to store our to-dos. In the blockchain world, we'll use Move's resource-oriented programming model to manage our data. Let's define what properties our to-do items should have. It should have an ID, which is a unique identifier for each to-do item. It should have description, which is the text describing the to-do item. And it should have completed, which is a boolean indicating whether the item is completed or not. In Move, we can represent this as a struct. So let's write our first bit of code. So what we've written here is the to-do item struct, which defines a new custom type called to-do item. And then we have hash store and drop, and these are abilities in Move. So store allows the struct to be saved in global storage, and drop allows it to be discarded when no longer needed. The ID U64, this is an unsigned 64-bit integer, perfect for unique identifiers. And then description string string. This will store the text of our to-do item. Note that we're using the string module here. Completed bool, a boolean true or false to track the item status. Now we need a way to store multiple to-do items. In Move, we can use a table for this. Let's add another struct to manage our list. So here's what it does. The use Aptos framework table imports the table type from the Aptos framework. And the struct to-do list has key. This defines our main struct. The key ability allows it to be used as a top level resource in global storage. And items table U64, comma to-do item. This creates a table mapping U64 IDs to to-do item. And then we have next ID U64. This helps us generate unique IDs for new items. By structuring our data this way, we are setting ourselves up for efficient storage and retrieval of to-do items on the Aptos blockchain. In blockchain development, we need to think carefully about our data structures. Unlike traditional databases, changing the structure of blockchain data can be challenging and costly. That's why we're putting extra thought into our design up front. Now that we have our data structures in place, let's get into implementing the key functions for our to-do list. We'll be creating functions to create, update, delete, and view to-do items. Let's start with the function to create a new to-do item. We'll call this function createToDo. This function takes two parameters, a reference to the signer, which represents the user creating the to-do item, and a string description of the to-do item. The function is marked as public entry, which means it can be called directly by users interacting with our contract. Inside the createToDo function, we first get the address of the signer using signer address of account. This gives us a unique identifier for the user creating the to-do item. We then check if a to-do list already exists for this user. If it doesn't, we create a new one using the move_to function. This is a crucial step because it ensures that each user has their own personal to-do list. Next, we borrow a mutable reference to the user's to-do list using borrow global mute. This allows us to modify the to-do list. We then create a new to-do item with the next available ID. the provided description and set its completed status to false. We then add this new item to our table using table add. Finally, we increment the next ID for future use. This ensures that each to-do item has a unique identifier. Moving on to updating to-do items, we have the update to-do function. This function allows users to modify both the description and the completion status of a to-do item. It takes 4 parameters: the signer, the ID of the to-do item to update, the new description, and the new completion status. In the update to-do function, we first check if the to-do list exists for the signer and assert if it doesn't. We then check if the to-do item with the given ID exists in the user's to-do list. If either of these checks fail, the function will abort with the proper error code. This ensures that we are only updating existing to-do items for valid users. If both checks pass, we borrow a mutable reference to the specific to-do item and update its description and completion status. For deleting to-do items, we have the delete to-do function. This function is simpler than the update function as it only needs to remove an item from the list. It takes 2 parameters, the signer and the ID of the to-do item to delete. Like in the update function, we first check if the to-do list and the specific to-do item exist. If they do, we use table remove to delete the item from the user's to-do list. Last, we have a helper function to view to-do items called view to-do. This function is marked with the #view attribute, which indicates that it doesn't modify any state. It's a read-only function. The view to-do function takes 2 parameters, the address of the to-do list owner and the ID of the to-do item to view. It returns a tuple containing the description and completion status of the to-do item. This function allows users to retrieve the details of a specific to-do item without modifying the state of the contract. Now let's talk about testing our smart contract. Testing is a crucial part of smart contract development as it helps us ensure that our contract behaves correctly under various scenarios. In our code, we have included several test functions that demonstrate how to use the move testing framework. The main test function is test to-do list flow. This function simulates a complete flow of creating, updating, and deleting a to-do item. It starts by creating a to-do item with the description test to-do. It then checks if the to-do was created correctly by using the view to-do function. Next, it updates the to-do item, changing both its description and completion status. After the update, it checks again to make sure the changes were applied correctly. Finally, deletes the to-do item and verifies that it no longer exists in the to-do list. We also have 2 negative test cases. In these test cases that our contract currently handles attempts to view or update to-do items that doesn't exist. They use the #expected failure attribute to indicate that we expect these functions to fail with specific error codes. To run these tests, you can use the Aptos CLI command aptos move test. This will compile your contract and run all the test functions, reporting any failures or errors. Running tests regularly as you develop your smart contract can help catch bugs early and ensure that your smart contract behaves as expected. Now that we have our to-do list smart contract ready, let's deploy it to the Aptos DevNet and interact with it. First, make sure you're in your project directory and compile the contract with aptos move compile. If there are no errors, we're ready to publish. But before we do, make sure you have an account on the Aptos DevNet. If you haven't created one, you can do so with Aptos init. This will prompt you to choose a network and you can select DevNet there and create a new account. Now let's publish our contract with aptos move publish. Once published, we can start interacting with our to-do list using the Aptos CLI. Here are some example commands. The first one is to create a new to-do item, then you can update a to-do item, then delete a to-do item, and then view a to-do item. To view your transactions and contract state, you can use the Aptos Explorer. Go to https://explorer.aptoslabs.com, switch to the DevNet, and enter your address in the search bar. You'll be able to see all transactions related to your to-do list contract. The interaction via CLI and exploration via the Aptos Explorer gives us a real sense of how our decentralized to-do list works. Each transaction is recorded on the blockchain, providing transparency and immutability to our to-do items. I've added complete code in description if you want to run it directly or compare it. With that said, this code represents our complete to-do list smart contract. It includes all the functionality we have discussed, creating, updating, deleting, and viewing to-do items. Each function includes proper error handling and makes use of moves resource-oriented programming model. Now you might make some errors while deploying this contract, but those will be mostly because of your local setup while installing Aptos CLI, and it varies for different systems. So some of the common errors are not setting proper address in config file. So make sure you do that correctly. And if you create a new account with Aptos init, then please fund that account with faucet before deploying because you need Octos for that. By building and deploying this to-do list, we've created a decentralized application where each user has their own persistent blockchain-based to-do list. This serves as a great starting point for more complex applications. In our next video, we'll build a fungible asset, and that'll be a really exciting project. So make sure you check that video out. Thank you so much, and I'll see you in the next one.